And if by the end of this you're still completely confused about this whole thing, don't forget my advanced functions videos are still up there on the YouTube channel. You can go back and watch the graphing rational functions video. It's the video that, and maybe I'll find the link and I'll put it up for you as well, so you can go through and watch all of this stuff, hopefully very carefully explained by me during COVID. Okay, back to here. Let's just be clear about what the question was asking us. It asked us to talk about vertical and horizontal asymptotes, and then find the limits at infinity, which actually are just the horizontal asymptotes. It's not asking anything more than that. It's just using new words to describe it. So I used my degree rules here, and I said, hey, the degree of the denominator was bigger, so the horizontal asymptote is y equals 0. And I need to tell you that if those rules are completely gone, or were never even in there, I'm about to show you another way to handle these things where you'll go, oh, I don't need the rules anymore. So if those are completely gone, worry about the ideas right now, not necessarily the rules. The idea is that some functions go off to infinity. Some functions settle into a horizontal asymptote at some value. Some functions settle into a horizontal asymptote at 0. Okay, and we'll keep working on how to find out which ones do what. Vertical asymptotes I'm less sympathetic about, because actually vertical asymptotes are just those restrictions that you learned way back in grade 11. It just seemed like this throwaway thing in grade 11, but those are where the vertical asymptotes are. And as far as knowing whether it goes to the vertical asymptote this way or whether it goes that way, that's all part of this lesson. It comes up knowing exactly how to put all this stuff together. Finally, once we have the horizontal asymptote, we're in great shape to do the limit. Or vice versa. If we start thinking about it as limits instead, we know what the horizontal asymptote is. Okay? So I think I finished that question. There was one little thing I sort of left out. And I want to go back to it for just a second. I drew it, but I didn't really talk about it. Right here. This particular function, I said, and I drew it, and I went, oh, it sort of goes like this in either direction. And I said, oh, the limit as x approaches infinity is positive infinities. It heads up this way. But I sort of left out this part here. And I should have wrote here as well, limit as x approaches negative infinity happens to be negative infinity. That one goes off down towards the negatives in that direction. And you're like, how do you know that by looking at it? It's in this lesson. This lesson sort of loops back on itself. So at some point I'll show you how to know what it's going to do on either side. That's why I just left it as infinity there, as I went, oh, we know it goes off to infinity. Narrowing down whether it's positive or negative infinity is a little bit more of a challenge. And the way we handled it in advanced functions is we just got all the pieces of the puzzle and eventually drew the thing, and we just found out whether it went to infinity by the other pieces of the puzzle that we had. X-intercepts, Y-intercepts, those type of things. Okay? One more. This function might have confused you if I had to give it to you in advanced functions, because it's not set up the way these ones are. I usually gave you with nice numerator, nice denominator, go to it. In fact, the assignment for that had a big chart on the first page where you had to do a bunch of these. Yeah? But let's use all our thinking now that we have available to try and attack vertical asymptotes, horizontal asymptotes, and limits at infinity. I'm going to start with the horizontal asymptote. And talk about what's probably happening here. If I send this thing to very large x values, this term here, this 5 over x, just imagine subbing in a large x value, say 1,000,000. This term will be 5 over 1,000,000. What kind of number are you going to get if you go 5 over 1,000,000? 0.00, like really small. I don't want to say nothing, but in the chapter of limits, we can really say nothing, pretty much nothing. So if that's going to head to 0, my horizontal asymptote's going to be at y equals 3. If that's confusing, think about typing in your calculator. Think if I type in 3 plus 5 divided by 1,000,000. 3 plus 0, 3. So this wasn't in the advanced functions course. We're now extending a little bit to go, can we use all our thinking now available to think about what horizontal asymptote you might get? By the way, you could get a common denominator here. turn it into one of these and just use your old rules. Okay? That's possible. Next, vertical asymptote. And again, I want to expand your definition of vertical asymptote, because in advanced functions, and in this example, you might have gone, oh, factor the denominator and set up the restrictions. Here, I can get the restrictions without doing really any work. I can just look at it and go, I know what x can't be in this particular case. What x value is not possible in this particular question? 0. Okay, so do you see how this one looks harder? But the same thinking that we are using allows us to survive it. Oh, he asked an important question. If I was talking about restrictions, I'd say x can't equal 0. But if I'm talking about vertical asymptotes, it's an asymptote right at 0, so it's x equals 0. And that mistake is made a lot in advanced functions, and I stare at it when it happens. And often I'll circle it on your assignment or your test and go, I know what you mean, but technically speaking, this is x equals 0. There's a vertical asymptote there, an imaginary line that says don't cross here. Okay? That was a mistake. The vertical asymptotes are at x equals -3 and -4. Yeah. Question? Yeah, I think I said 3 out loud and then wrote 0, and I don't know why. I did. I literally said 3 out loud and wrote down the number 0. Funny. Great catches. Okay, we're better. Hey, after that long teaching session, you look like you're drifting off to sleep. The break, we're back in, thinking this through a little bit. Okay, and the last thing they wanted was the limits at infinity. And I'm telling you, once you've done your horizontal asymptote thinking, you've done your limit at infinity thinking. But I want to modify it a little bit. I want to go at it a different way to give you a more powerful weapon. If I go limit as x approaches infinity of f at x, what I'm really looking for is limit as x approaches infinity of 3 plus 5 over x. And I can use the limit laws that we just did to say, okay, that means I can find the limit as x approaches infinity of 3 and add that to the limit as x approaches infinity of 5 over x. And this first part's easy. The limit of 3 is 3. 3 is always 3. And then I can just really focus on this part of it. If x goes to infinity, what happens to 5 over x? So we're talking about what happens if I do 5 over 1,000, 5 over 10,000, 5 over 100,000, 5 over 1,000,000. What kind of number? What's that going to head towards? It heads towards 0. And if that seems very familiar with exactly what I said for horizontal asymptote, it is, because it's the same thinking. Horizontal asymptotes really is what happens as we go out. Look at this one. What happens as I go out to infinity? And this diagram actually shows 3, just like that one happens to be. Are we a little better on vertical asymptotes, horizontal asymptotes, and heading off to infinity? A few more nods this time. Get used to it. Rest of this year. If it's not there, give me the shake, and I'll go again. This thing? What does that look like, he says? Well, let's get a look at it. Because I really want to see what your calculator actually does with this. Because your calculator is famous for dropping the ball on vertical asymptotes. It makes a mess of vertical asymptotes. And then I'm going to offer you another weapon, which you can't use in the test, but it's great for homework and so on. Oh, I can't get it from there. Hold on. It doesn't like when I use exe files from thumb drives. Like I couldn't just copy it over and use it or something. Okay, whatever. Menu. 5 for graph. What was it? 3 plus 5 over x? 3 plus 5 over divided by x. Execute. Draw. Zoom. Auto. Oh, there it is. You see how vertical asymptotes are so hard to see here? And it's really hard to see the horizontal asymptote as well. So I don't want you to forget when you're doing homework, a good friend that I hope I bored you with at some point. No, not bored you with. It's so good. It has better zoom features. You can't use it on tests or exams. Desmos. Really helps when you're like, how does that work again? What does that thing look like again? And that's what you were asking was, oh yeah, but what does this thing look like? What are we really talking about here? They've changed the look of things here a little bit, but you just click on graphing calculator, and then you go like y equals 3 plus, was it 5 over x? And what's great about this is once that's on my screen, I can move it around and do whatever I want. That is, I can check out the vertical asymptote there. Yeah? I can go up here and I can check out the horizontal asymptote. See how it's approaching 3 as I go out to infinity. Yeah? And this is really limit as x goes to infinity. That's what I'm doing here as I go along here. And then if I want limit as x goes to negative infinity, I just go this way. Yeah? So really good for helping you conceptualize what we're talking about in all of these graphs. Okay? Desmos. Superior to your graphing calculator in some ways. Certainly the zooming features and the quality of the graphs is better. Questions there? Give me this. Back to here. Back to here. Back to there. Okay, I'm good. Questions? So here's some definitions from advanced functions, but now using the limit notation instead. We have a more powerful notation available to us. The line y equals b is a horizontal asymptote of the graph. If as you go, limit goes x to infinity of f at x, you get that number, 3, was what we were just doing up there. Or if it does it on the negative side. We didn't see any that had different horizontal asymptotes on either side in advanced functions, but we will coming up, where it's possible to approach a horizontal asymptote on this side, but go off to infinity on this side. You can mix and match like that. And then a vertical asymptote means as you approach a value, take a look at this picture over here, as I approach an a value, the function goes to infinity this time. Yeah? So this way it was, the x's are going to infinity, the function goes to a number. Here, the x's are going to a number, but the function goes to infinity. That's the primary difference between vertical and horizontal asymptotes, is whether you're going to a number or whether you're going to infinity. Evaluate each of the following limits. Okay, this is the part that's supposed to be extension past advanced functions. I'm going to try and reach and grab both now. I'm going to try and go a step farther in all of these things in your thinking so that the rules aren't something you have to lean on anymore. If you really comprehend the rules and really understand those 3 rules, they're going to call you out. So the people that have to go, apparently they're going to call. So we'll know. That'll be our homework break. So the rules are there if you don't understand what's happening. If I can get through to you about understanding what's happening, you won't need the rules anymore. You'll be like, oh, I got it now. This says limit as x approaches infinity of 7 over 4 to the power of x. Now, in advanced functions, we never had dealt with anything 4 to the power of x in the denominator. It was always x squared, x cubed. Well, let's just think about, in our brain, what's going to happen here as I sub in very large x values. No matter how large an x value I sub in, the numerator is going to be 7. The denominator, though, is going to go 4 to the power of whatever my large number is. Just imagine subbing in 1,000 for a second. And exponential functions, as you hopefully know, I mean, the word exponential is used almost in regular language now to say something that got really big. If I sub in, well, even, I don't even need that big an x. Let's say it was an x value of 10. Watch this, 4 to the power of 10. 1 million. Yeah, you don't even need that big of x values before things go crazy. Hello? Absolutely. I'll do one more, and then we'll take our break. 4 to the exponent 100. Watch what happens. This is even worse than x squared. 1.6 times 10 to the power of 60. Like It's as big a number as you ever want to try and comprehend. So this thing heads off, the denominator heads off to infinity very, very fast. And so what I get is 7 over something very large. What kind of number are we talking about? 7 over something unbelievably large? 0. You see how that is? That's extending past the rules now. It's going, let's just use our brain here. What the heck is going on here? Right? And some are easy like that, and some get harder.